So supplied with the literature are templates for various parts of the instrument. These are the templates for the notes. And I'm just going to go quickly through how to just get the notes, the hole spacing on the notes. How the notes work is they just have a single hole on them, and the string is just held on one side. So it actually just supports the note from one side, stops the note moving by having the string threaded through the hole. So we just need to drill that hole and also put a bit of a chamfer on it to stop the string being worn too much. So this is the largest note. This is the C note, the largest C note, and I've got the spacing marked on the template. So one of the ways that you can do it, there's many different ways, but one of the ways that you can do it is to cut the template out pretty basically, and then use that on your blank piece of wood to mark where the note goes. So you can just place the template on top and then use the hole to mark where the hole goes, obviously. But if you use something sharp like the end of a pair of scissors maybe, you can actually mark where the hole's going to go through. That's one method of doing it. You could actually just measure it with a tape measure and then mark that on your piece of wood, and then find the middle and mark the middle there. So that's another way of doing it. There's no set way, but the templates will just give you that specification. Okay, once you've got a small dent in the wood, it's probably marked with something fairly sharp, you can drill through it. I'm using a 7.5 millimeter drill bit. You could probably get away with a 7 as well. But if you're not using a drill press, just try and keep the drill absolutely upright as you drill through. And I've got a plank underneath here. You obviously, if you're working on a nice table like this one is, you don't want to drill right through. So basically drill through the note, and then if you can use a countersink. So I have a countersink here. You can use a bigger drill as well if you don't have a countersink, but you just got to be a lot more careful. A countersink doesn't dig in as much, but that gives you a nice chamfered edge that won't hurt the string when it goes through. So that's the basic drilling of the note. We're using tuning methods these days where we're using mechanical machines to aid with the tuning. So a note like this would have been taken out using the end of a sander. So you're actually sanding the wood away. But traditionally, the tuning was done with an adze. So the theory behind it is that you're thinning out the note in the middle and you're causing the note to vibrate at a lower frequency. The relative weight of the ends to the thinness in the middle determines what the pitch is going to be. So if you add weight to the ends, you're going to lower the pitch, you're going to lower the frequency that the note vibrates at, and you're going to lower the pitch. And so traditionally, the thinning method of actually taking the notes down to pitch was done using an adze. Now, an adze is basically a chisel in an axe, a little African axe head. And that was what drove the little chisel end into the wood, and then you're able to then shape the wood to what you're looking for. Right up until very, very precise overtone tuning could be done using an adze. When working with an adze, you should be very careful that you don't make too many of those steps. Making steps in an arch like that will weaken it, and that will be the point at which it will fail if it's hit too hard or leant on too much. Whereas using the sander, you can get a much more even and smooth curve, and that makes for a stronger note actually in the end. Just by cutting a saw curve through the middle of this, so putting this over a circular saw, you will bring the pitch down. But that very big step, and at the point that it's cut through, will be the point that it fails. It will be, and then you can actually take more of it away, so you can cut it away along the blade a bit more, and that will be probably better than just having that single curve in the middle. So it is possible to tune notes that way. This I would not recommend, especially to people who are not used to machine tools, is to run it over the saw blade with the saw blade coming through the work this way. You've got to bring it up very slowly. You can't, and you've got to be able to support the note, because if the saw blade catches the note and pulls it in, it can pull your hand in. You can hurt yourself very badly. So it's not a method I would recommend to anyone. We use it to waste away a lot of the wood very quickly. Another way which we would use also and it would be safer in wasting away a lot of wood, is if we have a set of notes that is already tuned, you can then take that profile and draw it onto another piece of wood. So you then have the profile drawn onto another piece of wood, and then use a bandsaw to saw on the outside of that. So you don't want to go right up to the line. You want to be just inside that, and that wastes away a lot of the wood, and it speeds up the process of the actual fine-tuning at the end. That's the way I would recommend it. If you're designing a marimba, you start with your set of notes that are the sizes that you like, and what I would do to start with would be to do the lowest note first, to make sure that I'm going to get the lowest note in, the highest note next, so that I know that I'm going to get the highest note in, because if it's not going to be possible with that particular layout, then you've got to change your formula a little bit. But once you have the top and the bottom note, and you know that you're going to be able to get everything in between, tune everything else. Once you've tuned everything else, then you can look for your holes, obviously, and you can work out how you're going to build your frame. Marimba notes have been made with many types of wood. There's a term that we use, which is tone wood. So tone woods are woods that scientifically transmit vibrations a lot more efficiently than other woods. If you have a wood that's soft, or have a wood that the grain is tied together in a particular way, it doesn't transmit the energy through the wood as quickly. Tone woods tend to have the property of transmitting the sound. And it's got nothing to do really with the density of the wood, the hardness of the wood, the weight of the wood. None of those things really are that important in why a note actually sounds good. It has more to do with the structure in the wood. What we generally use in Southern African marimbas is kiat. You find it growing in northern South Africa, in Zimbabwe, in Malawi, in Zambia, Botswana. It's not a very hard wood. It's a very beautiful wood. It's been used for furniture and flooring and for stair treads and that kind of thing. But I think it makes much better instruments than furniture. The nice properties of it are it's easy to work. It's not very dense, and it also, over time especially, as it matures and you play it, it sounds better and better. One of the things that you need to note about when you look for wood for making marimbas is try and find wood where the grain runs downwards, as what we call quarter sawn. So if you can imagine, if the center of the tree is there, then the rings are growing outwards from it, and the wood that's cut down those rings so that the rings run straight through the wood is much better than what we would call flat sawn. So in terms of the way that the tree grows, that piece would be growing that way, so that the rings would be, actually it's the other way around, but the rings would be going around in a circle that way. So we're looking for pieces really that are where the grain runs across. That makes a note that's a bit stronger. It makes a note that actually sounds a bit better as well. You can't always get it. It's often just a matter of expediency that you just buy whatever wood that you can, and it will still sound good. It's just if you are making an instrument for yourself and you want to take a lot of time and put a lot of effort into it, then look for quarter sawn wood. So kiat is one of the tone woods that we use at African Musical Instruments. The other two are padauk, which padauk is a very close relative of kiat, but it's a very dark red color when you first work it. It eventually goes chocolate brown with exposure to light, but it's a very dark wood, and it has a slightly more metallic, strident sound than Kiat. Kiat sounds more woody, whereas Padauk will sound a little bit more glassy. And then for me, the ultimate wood is sneezewood. Sneezewood is a wood that grows along the coastal areas of southern Africa. It's been used in medicine and for ceremonies, to start ceremonial fires amongst the Xhosa. The sneezewood was carried around as a tinder in order to start fires in difficult situations. But it makes absolutely spectacular notes. The Chope people from Mozambique discovered that you can improve it even further by baking it. So by baking it in an oven, or as we do, or over the coals, braaiing it in effect, you basically tie up the resin in the wood. The resin actually polymerizes it. It forms almost like a composite, and the wood becomes incredibly hard and lasts and doesn't get affected by moisture or atmosphere. So from a musical point of view, I think this is probably one of the ultimate woods for making instruments. Unfortunately, it can't be obtained in large quantities. The only place we can get it now is from old fence posts. When colonial farmers first got to this area, they realized that the wood didn't deteriorate in the cold and in the weather, and they made fences out of it. And so now we use it. Now the only place we can get it is from fence posts. Anything else is illegal. You cannot cut new wood anymore. The trees are very, very highly protected. When you want to get a sequence of notes on a marimba, people always ask me, is the length critical? Is the width critical? In fact, there's a very large range that you can have between note lengths and also pitches. So by cutting it to a particular length doesn't necessarily mean it can be just one single pitch. You can change pitch according, you can have a vast range of length and still have a big range of pitches as well. So my suggestion would be, if you were designing a marimba, what you want to try and find out is where to rest the notes in order to get the best sound out of the notes. Now, the way the system works in a marimba note is that the middle is vibrating up and down, and the ends are vibrating up and down. But there's a point along between the middle and the ends that stands still. It's the point that is basically the fulcrum, the pivot point between the middle and the ends. And in designing a marimba, what you ideally want is a note supported exactly on the point that is standing still. Now, it's not always possible. You've got straight lines in a marimba, and you have to be constricted by the kind of design parameters that you're working on if you've got a normal straight frame. But it will give you the idea of where the frame should lie. So in order to find that, the sequence would be, in designing a marimba, would be to decide on your note lengths, then tune them to the pitches that you want. Once you have those pitches, you then start looking for what we call the nodes, or the pivot or fulcrum points of the note, the part that's going to be standing still. And the way to do that is to put something granular onto the note. I'm just using some sawdust from what we've just done in drilling it, and then to tap the note. So if you beat the note in the center, what happens is the vibration of the key is actually kicking the dust or salt or sand or whatever medium you want to use, just something very granular, into the position which is standing still. And that's really the point you want to be supporting the note. It's the part that will restrict the vibration of the note the least, and it's the part that will allow the note to breathe and produce the best sound. On the little marimba that I designed here, there's a pencil mark that I've marked over there, and that actually corresponds to the frame. I was restricted by the frame. I lengthened these lower notes afterwards in order to get a better sustain on them, because the short ones were sort of closing down too quickly. And so you can see our node point, our ideal resting point on this note is about there, but I've actually got the pencil mark over there. It does restrict it a bit. When you listen to the instrument, you can hear it being restricted, and so that's a constraint of the frame over the length of the note and where the node is. But it still will work. It's close enough and it doesn't restrict it too much. Okay, the system of tuning notes works on wood, but it can work on many other mediums as well. So, we talk about wooden instruments as being xylophones, xylos being wood and phonos sound. So it's the sound that you make from a vibrating piece of wood. But you can use other materials as well. So we also at African Musical Instruments produce instruments made with metal. So we call it a metallophone. This is a piece of aluminium, and as you can see, it's arched in exactly the same way as you would a piece of wood. Interestingly, you can make marimbas or bar percussion instruments out of ceramic or stone as well. That would be called a lithophone, which is stone sound. But you can make an instrument that has that uses a slab of stone as a vibrating member. So you're not restricted to wood in this system in the way the sort of theory of tuning and of vibrating bars to produce sound works.